Welcome, my dear students, to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 3, Normal Distribution, brought to you by Vitan Sir. In my previous tutorial, we studied about what is a normal variable, what is a normal distribution, the probability density function of a normal distribution, and the normal curve. Now, in that, I explained that the calculation of this is too tough. As you can see, the formula for that normal curve or the normal distribution was very tough. So we simplify it. How? We create a new variable known as the standard normal variable. We know, as I just told you, that the probability density function of a normal variable is very complicated. And so, to simplify things, we convert our random variable, the normal random variable x, into a simpler standard normal variable z. Okay, what we do? We convert our normal random variable x into a standard normal random variable or just standard normal variable z, where z is x minus mu upon sigma. Now here you know that mu is mean and sigma is standard deviation. So how do we calculate z? We subtract mean from the variable x and we divide it with our standard deviation. That is how we calculate the value of z. Now for the standard normal variable z, the value of mean mu is considered 0 and the standard deviation sigma is considered 1. This is due to because we are subtracting mean from the original variable, the answer should be 0, so it is 0, and because we are dividing with the standard deviation, it is 1. So mu is taken as 0 and standard deviation is taken as 1 for this standard normal variable, and therefore the probability density function of our standard normal variable is also converted. Because x is converted into z, our probability density function will become fz, where sigma is 1, so we can just ignore it. So 1 upon root 2 pi e raised to negative 1 upon 2 z square. So x minus mu upon sigma from our original density function is converted into just z square, where z is between negative infinity and positive infinity. Now mu is 0 and standard deviation is 1, so only range is z, which is between negative infinity to positive infinity. And here again pi is 3.1416 and e is 2.7183. We can draw a similar curve just like the normal curve using the variable z and its probability fz. We can calculate a similar curve. I will call it the standard normal curve. Now because x is a normal variable, it's a continuous variable, its curve is bell shaped. So similarly, z is also a normal variable. Z is also a continuous variable, and its curve will also be a bell-shaped curve, which has limits negative infinity and positive infinity, and its central value is z, which is mean, and it is 0. So you can see that on the central part of the curve we have 0 because mean is 0, so central value is 0. So all the value on the right side will be positive values up to positive infinity, and all the values on the left side will be negative values up to negative infinity. Now let's come to the main part of this chapter, or why we are studying this chapter is because we need to calculate probabilities. Now I just told you guys that the probability density function of variable x, that is the normal variable, is very complicated. Same, we converted it into a standard normal variable and we have the probability density function for the standard normal variable and we have a normal curve. But I just told you guys that the normal curve or the standard normal curve, we call it, it represents the probabilities of the different values of standard normal variable z. Therefore, in normal distribution, we calculate probabilities based on the curve itself. So we have this curve here, okay, negative infinity, positive infinity, and mu, which is 0. So this whole curve, okay, the whole curve represents the total probabilities. So see this highlighted part here. This highlighted part is actually the area under the curve, and we assume that this area under the curve, because this is a probability curve, okay, so this curve naturally depicts the probabilities of the various values of the variable z, which is between negative infinity and positive infinity. So the whole area of the curve depicts the probability, and we know that the total probability of all the variables is 1. Okay, that means the whole highlighted part has a probability value of 1. I will repeat it once again. The whole highlighted part has a probability value of 1, and the mu is at the exact center, and it divides our curve into two equal parts. So the curve has total probability 1 and it is divided by mu at the center. So because it is been divided into two equal parts, the both parts have the probability 0 0.5, 0 0.5. That means the probability from 0, that is the central value, from to positive infinity is 0 0.5, and the probability from central value 0 to negative infinity is also 0 0.5, and the probability from negative infinity to positive infinity, total probability is 1. Okay, so the area on the right side of the mu is depicted as probability x, which is greater than equal to mu, but we convert it into a standard normal variable. So x is converted into z, and mu is 0, so mu is converted into 0. So the probability that the value of z is greater than or equal to 0, that is from 0 to negative infinity, is 0 0.5. Similarly, the area on the left side, which is less than the 0 value, is depicted as x less than equal to mu, which is converted into a standard normal variable, which is x is converted into z, mu is 0, so z is less than equal to 0, that is negative infinity to 0, it is 0 0.5. So this is how we show our normal curve, and these are the probabilities depicted by normal curve. I have told you many times, we know that even after the simplification, the probability density function of standard normal variable is not easy to calculate. So there is an easy way out. For this purpose, the statisticians have already prepared a table with ready-made calculations. That means they have put all the possible values of the z into the equation and calculated the answers, and they have created a table of ready-made calculated answers of all the possible values of z. We will use that table, which is given at the last page of your textbooks, okay, and that table will be provided in even your board examinations. That means in even your board examinations they will give you that ready-made table, so even you don't have to memorize the values, although with practice you will remember certain values, but you don't have to memorize the whole table. They will give you that table, so we will use that table, the ready-made answers of probabilities, as a reference for each and every calculations related to this chapter. So we are not going to solve that formula, okay, just like in the first or second chapters we had to put our values into the equations and then find the answers. We don't have to do this in this chapter. That's why this chapter is a lot easier than those chapters, previous chapters, because we are not calculating using the formulas. We directly have those values. We just need to put those values into our some combinations and get the answers. I will explain you shortly what type of combinations I am talking about right now, but first let's take a look at the table here. Table of standard normal curve. From this you can see there is a curve here, z is equal to 0, in the center value is written, and z equal to z1. That means the area from 0 to z1, okay. So those values are depicted in this table. Now this is the whole table. Okay, whole table, every possible probability values are there in this table. But right now I'm not going to explain the method of using this table. Rather, I will explain them when we actually do the practical sums. At the time of practical sums, I will in each sum I will show you this table and mark how we actually calculate the probabilities using this table. But remember one thing, that all the values of this table are given with respect to the value of mean. That means I have told you that the continuous variable is a interval value. Okay, so we need to calculate probabilities between two intervals. You can just see it here. It is here. This you can see here, that this is a interval given. This highlighted part is actually the probability value. We know that the whole part is 1, so some part of it we will need to calculate each and every time. So this highlighted value is given, but how to calculate this highlighted value, how to see it from the table. So each and every time this highlighted value we have to calculate it with respect to the central value. That means one point can be anything, but one point should be the central value. Then only we can calculate the probability, because all of these probabilities are given as such. 0 to, you can see here the values are there. This is 0.10, that is 0 probability. See here, 0 0 0, that means central value only, so it is 0. Then this is 1. Okay, sorry, this is 1.0, so that means 0 to 1, the probability is 0.3413. So that way these are the distances from the basic 0 value. Okay, these are the distances, and based on those distances they have given us highlighted values. That means each and every time one value should be the central value and second value can be anything from this curve, and doesn't matter whether it is on the right side or the left side, distance is same, because this is a normal curve. Just remember from your 11th, the symmetric distribution, the distance on both the side of curves should have the same area, was what we studied in the 11th. So same thing we have to follow here, that whether it is one on the right side or one on the left side, the answer will be same. That's why they have not given us any positive or negative values. Even if it's a negative one, the answer will be same. Even if it's a positive one, the answer will be same, because on the right side we have positive values, on the left side we have negative values, but each side the total probability is zero point 0.5 zero point 0.5, the total is 1. Okay, uh, let's, when we start with the actual sums, I will again explain it how we do it. Okay, but before we start with the actual sums, let's take some basics. Okay, uh, just see what we do. Suppose we want to calculate probability between the interval mu and a constant value on either side of it. Let's see what I'm trying to say here. I will highlight the part for you. Now this is your normal curve. Okay, central value is mu, and now there is a constant value a, and you want to calculate your probability value from mu to a. That means this highlighted part you want to calculate the probability for. How will you do it? First of all, we have to convert our x values, because mu is actually a x value and a is also constant x value. We will convert that x value into a z value. That means our mu will be taken as 0 and a is an x value. So when I convert a into a z value, it will become z1. So we are taking values, the interval between 0 to z1. Now from our table we directly have that 0 to z1 value. As I told you, one of the values must be 0. We have that 0 here. So when we calculate probability, we are calculating values between 0 and z1. So we will write it like that in notations. Probability where 0 is less than equal to z is less than equal to z1, means our variable is z, which lies between two intervals 0 and z1, and for that we are calculating probability. Now as long as one of our values is 0, you see here 0 and z1 two values are there. As long as one of our values is 0, we can directly check out the value of z1 from the table and get our probability answer. Okay, so no worries, right now one of the value is 0, so we don't have any problems. But right now it is on the right side, right? what if this curve is on the left side, this highlighted part is on the left side of the curve? At that time we have another constant b which is on the negative part of the curve, and I'm going to highlight it like this. So we first have to convert it into our z values. So mu will be taken as 0 because it is the central value, and b I will just name it randomly as z2. So right now our probability of z lies between 0 and z2, but which is the lesser value between z2 and 0? Which one is the lesser value? Naturally z2 is the less value, 0 is the greater value here, because z2 is a negative value and 0 is at the center. So when we write down the notations, always start with the lesser value. So right now z2 is less than z is less than 0. That means we have to find the probability where z lies between z2 and 0. Once again, one of the values is 0. So for this probability also we can directly calculate the value from table. Okay, let's just assume that this z2 is 1, negative 1, but in the table it doesn't matter whether it's a negative one or it's a positive one. Okay, so if z2 is 1, we need to calculate probability between 0 and 1. So just check out that 1 from the table and you will get your probability 0.3413. So directly you will get your answer, that the answer for this probability is 0.3413. Okay, I will explain it in the sums, but I'm just trying to give you an idea of how it happens. So as far as one of our values is 0, we can calculate the probability. But the problem occurs when one of the values is not 0. I will come to that afterwards. Now, suppose our interval spans both the sides of mu. If you did not get what I am trying to say, I will just highlight it for you guys here. Let's assume this is our normal curve and there are two constant values, b and a, and we need to calculate the values between b and a. That means from b to a, the highlighted part we need to calculate value for. Now naturally there is a problem here, right? Because one value is b, another value is a, and if I am converting these values into my z factors, so I will name mu as 0, a as z1 and b as z2. Naturally I am giving the same symbols just like in my previous explanation. So right now what I am calculating here is from z2 to z1. The probability of z lies between z1 and z2. There is no 0 here. So what we are going to do? In notations I am going to write, I will always start from the lesser value. So z2 is less than z is less than z1. What is it? z2 is less than z, which is less than z1. But I only have probabilities from 0 and there is no 0 here. So naturally what I am going to do here, okay, first I will calculate probability from z2 to 0, this part, and then I will add 0 to z1 in that. So I will get this total value. We can use simple maths here, which we studied in second and third standards, that first we will calculate from z2 to 0 because this part is there, and then we will calculate from 0 to z1 the second part, and then we will add both the parts. So it will be something like that, z2 to 0 plus 0 to z1. Now if you assume that z2 is 2 value and z1 is 1 value, so you can just calculate the probability of 2 from the table, 1 from the table, and just add those both probabilities. So you will get from negative 2 z, that is z2, to positive 1, that is z1. Okay, some at the time of sum I will explain, but right now I'm just giving you an idea how it is done. So if we have this type of probability which is on the both sides of the mu, then we just break it up into two parts, correct, and add those both parts to get a single value. Simple as that. Now suppose our interval is a part between mu and infinity on either side. Let's see what I mean by that. Sometimes words are not enough to explain, figures explain better. So our interval is a part between mu and infinity. So let's see, A is there, B is there, and this is what we need to calculate. Now the problem here is neither A or B are connected with mu, and mu is not even in between them. A and B are both on a single side of a mu, and they are not even touching mu. And what is my rule here? That if I want to calculate probability, one of the values must be 0, that is mu. So let's convert these values first. The second option here is, suppose these values are on the right side of the mu. Okay, so whether they are on the left side of the mu or right side of the mu, we have to follow the same system. First we will convert these values. Okay, we are converting x into z value, where mu will be 0, a is taken as z1 and b is taken as z2. See, I am putting the values in the figures here, you can see. Okay, I just put these values in the shapes I have drawn. Okay, so how we are going to do this? Now it is not possible actually to calculate interval value of a and b directly. Okay, we can't directly calculate a and b because area value is available only with respect to mu. So what can we do? Okay, what can we do? First of all, let's write down what we are supposed to find. First of all, in if I am talking about the left figure here, what I am supposed to calculate is the probability value between A and B, that is between Z1 and Z2. So let's just write down that equation first. Z1, Z, Z2. Z1 is less than Z, which is less than Z2. Always start from the left side. So the highlighted part here is Z1 to Z2. So Z1 less than equal to Z, less than equal to Z2 is what I am going to calculate here. Okay. Now the problem here is that I don't have a 0, but let's see. I don't have a 0, but I do have value from 0 to Z1. Yes or no? I do have the value from 0 to Z1. So I will find that first. That is Z1 to 0 I am calculating first. Z1 less than equal to Z, less than equal to 0. And I also have value of 0 to Z2. Yes or no? I also have a value from 0 to Z2. That means I have Z1 to 0 and Z2 to 0. So what if I just make a difference? So Z1 to 0 and Z2 to 0. If I make a difference of this, I will get the remainder, that is Z1 to Z2. I'm just getting an example here, that it's like if I am living in Valsad, I know my distance of Valsad to Surat. I also know distance of Valsad to Ahmedabad, and I want to calculate distance of Surat to Ahmedabad. So I will first of all take a distance of some 400 kilometers from Valsad to Ahmedabad, and then deduct that 100 kilometers of Valsad to Surat, and I will get my distance of Surat to Ahmedabad as 400 minus 100, 300 kilometers. So this is something like that I directly don't know what is Z1 to Z2, but I know 0 to Z1 and 0 to Z2. So I will just take a difference and I will get the remainder, which is the exactly what I want. Same thing we will do with the second part also. The positive, this is a negative side, so right is a positive side. So in there we are going to do the same thing, because I want to find the probability of Z1 to Z2, which I don't know, but I have mu to Z2 and I also have mu to Z1. So 0 to Z2 probability I will calculate, and from there I will subtract the probability of 0 to Z1, and I will get the remainder, which is Z1 to Z2. It's simple as that. Okay. Now suppose our interval is between a constant and infinity. Let's show you the figure itself. This is A, and I am highlighting part from negative infinity to A. What I am doing, I am highlighting a part from negative infinity to a. And then this is another figure where I am highlighting a part from b to positive infinity. Now these are the probabilities which I need to calculate. Once again, there is no central value here. Converting mu a and b into 0, z1 and z2. Look at the figure properly, huh? See, I have just put the values a as z1, mu as 0, mu as 0, b as z2. So now what I need to calculate here first, that infinity value and a value, b value and infinity value, and I don't have any zeros in there. So, but we know that 0 to negative infinity, the whole left part is 0.5. I just explained that in my previous slides, right, where I explained that the whole curve is 1 and right side part is 0.5 and left side part is 0.5. So 0 to negative infinity is the left side part, the whole part is 0.5, and similarly 0 to positive infinity is the whole right side part, and that is also 0.5. So if I put that knowledge into play here, first of all, I need to calculate for the left side part negative infinity to z1, which I don't know. But I can draw negative infinity to 0, right? Which is negative infinity to 0. And from that, I can naturally subtract that z1 to 0. This is the same concept which we studied in my previous slide. Previously, we studied the same concept only, getting the difference here. So, negative infinity to 0 and z1 to 0 we are calculating, but in there negative infinity to 0 is the whole left part, which is 0.5. So actually what I am going to write 0.5 minus z1 to 0, and I will get that difference negative infinity to z1. Similarly, in my second part also, I need to calculate b to infinity, that is z2 to infinity. So first of all, I am going to calculate value from 0 to infinity, and then I'm going to calculate value from 0 to z2. So 0 to infinity minus 0 to z2, but infinity is 0.5, so 0.5 minus 0 to z2 is what I'm going to calculate. So in this tutorial I'm going to end my lesson here. Reason being, it has been a lengthy tutorial. Next time, I will start with the characteristics of the normal distribution and standard normal distribution. Both have different characteristics. Okay, so they are a big set of characteristics and very important characteristics. And also next time, let's see if after doing the characteristics, I will try to solve 2 to 3 sums with values and tables, and in that I will explain you practically how we use tables and how we calculate probability and all that. But before that, I tell you guys what I have done here is very important. This formats, this steps, this drawing of this diagrams, it is very important for you guys to draw these. And so I tell you guys that draw these in your notebooks, write your notes properly, okay, without fail. So next time I will see you with the characteristics and some practical sums, so stay tuned for that. See you guys. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.